Hey everyone, Lex here. I'm a solution architect here with Bitrise, and I'm very happy to guide you through this short demonstration, particularly on using Bitrise Build Cache and how to identify and inspect when invocations may be behaving differently. This could be an impact in speed, cache hit rate, or just overall your build behavior varies between different invocations. I'm already inside of my demo workspace where I'm in the build cache dashboard here that you see, and it's essentially presenting me with a list of invocations. This is a project, or this is a workspace where a lot of projects are built across different build systems, and I do have build cache set up for all of them. You can see here Gradle, Bazel, and Xcode. I am going to be focusing on Gradle. I have some recent runs in here that I want to inspect, and you'll see that while I can go ahead and filter down like the workflows that executed those invocations, the specific commands, etc. I'm going to be focusing about like one of my most common ones is assemble, debug, and lint. Assemble, debug admittedly has a higher cache hit rate historically, just because of the amount of data and reusability that I find there. But you'll see that when I inspect some of my commands, there are some discrepancies at times. So I have this actually particularly long build. And what I want to do is I want to click on this compare button that you see here on the top right. And rather than checking an invocation individually, when I hit compare, it's letting me select two of them. And you'll see why in just a second. But I have this actually pretty fast lint execution, or the command duration, at 2 minutes and 39 seconds. That's not necessarily the same amount of the length of the overall build, but it's an important metric to review when you're checking the invocations from Build Cache. And then you'll see that this other one was much slower at 11 minutes. So I want to go ahead and compare those two. And what this does is it actually presents you with a really nice UI diff checker, essentially, that is enabling you to see both the differences and what stayed consistent between the two different invocations that come from two different builds. And you can see here, like, I could go ahead and inspect the builds as well if I want to check the differences there. But this is a really nice way to visualize the essentially what's available in terms of the environment. So it'll even let you separate these categories. So you have infrastructure, you have the Java environment. You want to go ahead and identify if there's particularly different differences there. Let's say your invocations got way slower whenever you switch to a new version, right? Like that would be a good way to kind of spot that here and identify if that could be the reason why your invocations slow down. You'll see the Android environment is set up here, the compilation and target SDKs, some information about the source code, as well as the strictly caching information, right? I can go ahead and make this shorter and compress it down to only showing me the changes. A lot of this stuff here is going to be like IDs and unique things that are meant to be different between the different invocations. So not too much information there. But, I try to identify if there's patterns perhaps across like the node, if there's a specific region or something like that. However, the other things that I look at is, the straight up caching information might give me a good idea here of why there was such a stark difference in the duration of these. And you'll notice that when it comes to the caching information, that first build actually had 0 uploads, and it also had a much higher hit rate of 40% compared to the 13%. And so when looking at the amount of objects downloaded, the sizing here, like I said, there was a lack of upload here versus here. This step actually had to handle both downloads and uploads. And with the smaller cache hit rate at 13%, that really does mean that less stuff was able to be reused. And so the additional percentage was really spent on doing those things from scratch. And sometimes you may find yourself with the invocation, one of the components that it missed or it wasn't able to reuse, maybe due to some sensitivities of the changes where it felt like, okay, let's go ahead and do this from scratch again. That could have been one of the larger tasks, right? And from the Gradle standpoint. And that could have led to the much longer execution here. So when reviewing this, this quick check here in the comparison has allowed me to see that rather than any environmental changes across like how my Java or Android is configured, even the machines, nothing's really throwing any red flags there. It does seem like the duration increase is solely due to this hit rate. And from here, I could go in a variety of different ways. I could go ahead and start identifying what were some of my lengthier tasks in that particular invocation that took long, and try to identify if there's a task that I can go ahead and reduce the sensitivity to changes, right? If the more granular that these tasks are, the better, because then, you know, you have some micro changes that may affect certain areas, but not the bigger picture, versus if you have a lot of things happening in a single task that is sensitive to change, then that's bound to be like very prone to needing to run from scratch. This is essentially how this comparison works. This is my approach to be able to take a look at different invocations when I see patterns of, once again, either slowdown, or maybe there's one that's really fast and I want to understand a little bit more as to why. But yeah, I highly recommend that you leverage this when it comes to Build Cache. This is true again for all the other build systems. When you are listing out the invocations, you have that compare button. I hope this was useful. Take care, everyone, and happy building.